So welcome back to our YouTube channel Sai Embedded Automotive Domain. So today we are going to discuss about the diagnostic. So what is diagnostic? So we see in the previous videos like CAN and important questions on the CAN. Most of the interview questions I have cleared. So the similar way, or this is also the one of the uh, important topic in the automotive sector. So we are going to start with the diagnostic topic. So hello all, welcome back once again. Sai Embedded Automotive who are subscribed. We have reached 200 subscribers. So I'm looking also will get the more number of subscribes to so that I can also get to more videos to each and every members who are looking for the jobs. So coming to the diagnostic, what is diagnostic? For example, modern vehicles are packed with full of modules like ECUs and another functional clusters. Types of ECUs we have already we have discussed like body control ECU, light control ECU, and vehicle control ECU and engine control ECUs. For example, if any faults is occurred in the ECU, like a malfunction indicator light will be appears in the dashboard. The similar way, some features of the diagnostic we cannot identify a faults, like for example ABS sensor was failure. So how can we identify with our eyes? We cannot identify, so we'll get the malfunction indicator like brake failure was appeared. So similar way we can identify some critical functionalities of the failures in the only dashboards. So coming to the what is diagnostic? Diagnostic as a word suggests to identify a cause of a problem. Where ECU find a problem, it stores that as in the diagnostic trouble code. As you heard, right, DTCs will be stored in the electrical erasable programmable read-only memory. So we call it as EEPROM. So a diagnostic equipment which allows the diagnosis and fix the problem with the vehicle and with the help of the diagnostic tools. Okay, so let's begin with the diagnostic, like how this diagnostic, which ISO will follows. Diagnostic will follows the ISO 14229, as you know everyone. So this is about the diagnostic. If we see in his hand one diagnostic tester tool is there, he is connected to the OBD connector, so he is identify any faults in the vehicle so he can read that information. In generally diagnostic we have already discussed, like how this 14229 came into the picture. So what is UDS? So UDS is a Unified Diagnostic Services, is based on the standard KWP 2000 for K-line and CAN. It was developed with the goal of standardization, different implementation of the procedure standard, new requirements for further development in a technology. So UDS describe the 7-layer protocol like diagnostics layer based on the extended version of the protocol KWP 2000 on CAN ISO 15765-2. So currently we are following the diagnostic 14229-1. So let's begin with a brief example about the 14229-1. It has been established in order to define the common requirement for the diagnostic system. Whatever the series data link is, like it is ISO CAN TP. As you know, CAN TP, if it is more than 8 bytes, we can send up to more than 8 bytes, like 64 bytes of data or 4095 bytes of data we can send. So what is the architecture of the ISO 14229? If we see, the server ECU are connected to the client tester over an internal data link and directly connected to the diagnostic data link through the gateway ECU. If you see the figure, client and server. Who is client? Client is a tester. Server is a ECU. So server directly connected to the diagnostic data link, and here we have types of vehicles, vehicle 1, vehicle 2 and vehicle 3. So these will be connected with respect to the, as per the architecture. So the basic principle, so in a diagnostic we have a, how many types of addressing modes are there? Two types of addressing modes are there. What is addressing mode? Why we are using the addressing mode? Because addressing modes defines how many ECUs need to connect. For example, if I want to communicate with single ECU, I can go with the physical addressing mode. And if I want to communicate with multiple ECU, I can go with the functional addressing mode. if you see physical addressing mode, it is the point-to-point communication between the client and server. Functional addressing mode, it is the broadcast communication and used for the addressing group of ECUs. And if we see the standard and extended frame format, like it's represents with the start of frame, message identifier, RTR bit, IDE, DLC, data byte length, CRC check, acknowledgement field, end of the frame, and ISO frame. Similar way, in the extended frame, we have the 29-bit message identifier for the diagnostic over the comm communication, start of frame, message ID, IDE, 18-bit identifier, RTR, R1, R1, R0 for reserve purpose, DLC, data byte, and CRC acknowledgement, end of the frame, and ISO frame. So this is about the normal diagnostic follows like ISO. We discuss 15765. It's a detailed standard for formatting the data field of a CAN message. Permits to transmission of the length from 00 to 409 bytes of data. So we'll do one another video on the CAN-TP in detail, like how the flow will be happen in the CAN-TP, like single frame, first frame, consecutive frame, the next video. So coming to the diagnostic, like diagnostic was organized and it was divided into the 6 functional unit. What are there? First, diagnostic communication manager and data transmission, stored data transmission, input and output control, remote activation of routine line, and upload download. So the most important features in the diagnostic is request and response message. So what is request message, what is response message? Request will be given by the tester, response is getting from the ECU. So if we discuss about the request and response, these two things should be comes under the mind. Request will be provided by the tester, response will be comes from the ECU or a server. So if we see the request format, like request frame format type and message length, and service ID, subfunction parameter, and data. For the response, if it is getting the positive response, it will add plus 40 and the respective subfunction and data. Why this plus 40 is added, that will be discussed in the next slide. And coming to the negative response, why this negative response, we call it as NRC. It will represents with the 0x 7f and service ID and respective NRC. So what is diagnostic service? Like in generally the information exchange initiated by the client in order to require the diagnostic information from a server, and it modified its behavior for the diagnostic purpose. Coming to the service ID, what is service ID? Each request service shall be assigned a unique service value. Each positive response service shall assign a corresponding service ID value. All the request message have bit 6 bits, and if it is equal to 0, all that is the request message. All the positive response message having the service identifier bit is equal to 1, then it is a positive response. By seeing these two, y plus 40 will added, you can also get easily, because the 60 bit will be enabled for the positive response. So the 60 bit will comes under the 4 and the 40. If we see the 1 byte, consider as a 1 byte, if you take the 60 bit you enable and make down, the 540 will come, you can also come to know. Coming to the NRCs, why this NRCs will come into the picture? So whenever we have set of NRCs are there for the rejections, like 10 general reject, and 11 service not supported, 12 subfunction not supported, 13 incorrect message length or invalid format, 21 busy request, and 22 condition not support, and 24 request sequential error. So what is general reject? The request operation has been generally rejected. Service not supported. The requested service is not supported. Subfunction not supported. The requested subfunction is not supported. Incorrect message length or invalid format. Message length or format of the message is not valid. Busy repeat request. The ECU temporarily cannot perform the required operation. The tester will repeat the request. Next, condition not correct. The request condition is not met. Request sequential error means the following request sequential sequence is not correct. And 31. Request out of range. This code shall be sent if the user optional service access data record contains the invalid data. Next, 35. Invalid key. This NRC will be used in the 27 security access. We'll discuss the next slides. The value of the key does not match the server internally stored calculated with the key. Next, 36. Exceeded number of attempts. If the delay timer is active due to the exceeding the maximum number of allowed false access attempts. 7F negative response service ID. It represents with the negative response service identifier. 78 request correctly received response pending. The ECU received the request correctly but has not performed the request operation correctly. Next, security access denied. Data identifier is secured and the server is not allowed to unlock state. So, coming to the diagnostic session control. So what is session control? Different sessions are running in a ECU. The ECU will always remain either of the sessions. Like diagnostics is a one of the session where ECU will respond to the tester. Means default session, from the default session to another session, from the another session to the same session, or extended session. Yeah. Coming to the diagnostic session control. So what is diagnostic session control? It represents the service ID 10. Diagnostic session is a basic communication between the ECU and the diagnostic tool. During the ECU can be analyzed in a particular session. A diagnostic session enables a specific set of diagnostic services and or a functional in the server. Basically, three different diagnostic sessions are there: default session, extended session, and ECU programming session. Normally, a control device is so called as a default session. Here are the just small and non-critical part of the diagnostic services can be used, and one is small part of the measurement and control data can be read but not actually written. Coming to the default session. What is default session? When we turn on the ignition, so all the uh, ECUs will be in the default session. And what is programming session? The flashing, uploading and downloading, booting, everything is done in the programming session. And coming to the extended session. In the extended session, if I want to communicate with other service ID, I can go with the 1003 extended session. Let's see the request message, how this request message will be there. If you see CAN ID 0x7EO and DLC and the PCI protocol control information and service ID 10 subfunction 03 extended service session control and respective data. And coming to the positive response, if we compare, the positive response will be added with the service ID plus 40. If we see in the previous it was 10, if it is added with the 40 it will be 50, and respective subfunction and supporting data came from the ECU, and this represents the negative response. Why this represents the negative response means the PCI length was the having the negative response represents a 3 and represents 7F as an NRC, and 10 is a service identifier. So what and all the NRCs will support in the 10 service ID? So in generally it will support the 12 subfunction not correct, and send if the subfunction parameter in the request message is not supported. 13 incorrect message length or invalid format, the length of the message is wrong. 22 condition not correct, code shall be retained if a critical for the request diagnostic session are not met. So these are the supported NRCs will be there in the 10 service ID. Next will begins with the another service ID ECU reset. So the service identifier number is 11, that is for the ECU reset. Why this ECU reset is used? Service is used by the client to request the server reset. Based on the reset type, server performs the corresponding reset. So What is hard reset? What is soft reset? Hard reset is a power off reset. The ECU shutdown and power up from the bootloader. A delay of application 500 milliseconds is required before the ECU can resume in the normal operation after the hard reset. Coming to the soft reset. What is soft reset? A soft reset is a partial system reinitialization when when the service is executed, the module shutdown and branches of the server application in the entry point. The bootloader is the bypassed and RAM partially initialization and the NVRAM mirror is reused. A delay application is 150 milliseconds is required before the ECU can resume into the normal operation of the soft reset. In generally, we can also tell a soft reset is a ignition on off also. Okay, next key on off reset is like similar way. So in this 11 service ID, the supporting NRCs will be 12 subfunction not supported, 13 incorrect message length or invalid format, 22 condition not correct, and 33 security access denied. Here the last one is added in the ECU reset. For example, why this 33 came into the picture? What is security access denied? In generally, any other third party people can access the ECU, means is there any security? So no other third party can access with the ECU information. That's the reason the 33 NRC will came into the picture. Security access denied. Only particular authorized service center guy, means who was having the license for the tool, so they can only unlock the ECU and they can only reset the ECU. So coming to the request and response message, you see request we have sent 11, the service ID is subfunction 01 and respective data, and response is coming into the 5101 and respective data. Next, coming to the 27 service ID security access. So the purpose of the service is to provide means to access the data or diagnostic service which have restricted access for the security or a safety reason. Security access is a ECU granted by means of an OEM defined seed and key procedure. Typically, multiple levels of security access exist here. So, what type of multiple types of securities we have? Example: tester requests the seed, ECU responds with the seed, tester sends the key appropriate for the seed receive, ECU responds that key was valid, then unlock itself. Here, don't confuse ECU is the server or a server also the ECU. Client or a tester will be the same. Okay. So coming to the request and response message. So we will give the request 2701 or 2702. Okay. So based on the request and response message, first we have request the security access, then we'll get the positive response from the server, and again we need to send the appropriate key value, then the ECU will be enabled, means we can able to perform the respective functional activities. What we can do, we can also do the uploading or downloading the features. How this request and response will be happen? Here we have set of subfunctions are there. 01 is a request seed, requested seed with the level of security defined by the vehicle manufacturer. Next, 02 subfunction, send a key with the level of security defined by the vehicle manufacturer. Next, 03 request seed with the different level of security defined by the vehicle manufacturer. Send key 04, the different levels of security defined by the vehicle manufacturer. So, and some other 5F also there, request seed value, and some other IS4 reserved also there. So those will be used for the accordingly OEM things. So coming to the NRCs, what are the NRCs we have in the security access? So let's begin with the NRCs. 12 subfunction not support, 13 incorrect message length or invalid format, 22 condition not correct, 24 request sequence error, 31 request out of range, 35 invalid key. So request out of range, what means code shall be sent if the user optional security access data record contains the invalid data. What is invalid key? If the send if the expected send key and subfunction value is received and the value of key does not match to the server internally stored or calculated key. So here some OEMs will follow the handshake technique for the uh, key and seed and key techniques. So based on the OEMs it will depends. And 36 exceed number of attempts means send if the delay timer is active due to the exceeding the maximum number of allowed in the each case. 37 required time delay not expired, send if the delay timer is active and request is transmitted. Next, what is tester present? This is one of the most important service ID. So the the service is transmitted periodically indicates the tester presence in the ECU in the current diagnostic. In generally, for example, we have the tester present 3E service ID. Okay, so if I want to stay in the one particular service ID, if I am doing some read operation, so should not come back with the default session. So the tester present will be sent periodically, either depends on the 50 milliseconds or 100 milliseconds or 500 milliseconds based on the application. So prevents the server from the automatically return to the default session. Coming to the frame format request, like 3E, I'm sending the 3E and respect to 00, and I'm getting the positive response with respect to the 7E and 00 with the PCI length 02. So next one is the communication control. So this service is to switch off or on the transmission reception of the server. So we'll discuss with one by one. So how many subfunctions we have? 00 contains the enable RX and TX. So what is RX? It's a receive. And what is TX? It's a transmission. 01 is a enable RX and disable TX. And 02 is a disable RX and enable TX. And 03 subfunction is a disable RX and disable TX. So what is enable and enable RX and TX is this value indicates that the reception and transmission of message shall be enabled for the specified communication type. Next, 01 subfunction enable the RX and disable TX. This value indicates the reception of a message shall be enabled and the transmission shall be disabled for the specified communication type. And coming to the 02 subfunction disable RX enable TX. This value indicates that the reception of a message shall be disabled and the transmission shall be enabled for the specified communication type. And the last one is 03 subfunction disable RX and TX. This value indicates that the reception and transmission of message shall be disabled for the specified communication type. So for communication we have the request and response message. So the service ID will be 2800 subfunction we have given, and respective positive response it is getting the 68 and 00 subfunctions. So let's begins with the NRCs for supported for 28 service ID. So here the same way 12 subfunction not support, 13 incorrect message length or invalid format, 22 condition not support, and 31 request out of range. These supported NRCs will be having the for the 28 service identifier. Next, coming to the DTCs. What is DTCs? The control DTC settings service shell has been used by a client to stop or resume the settings of the diagnostic trouble codes. So 01, the server shall resume the settings of the diagnostic trouble codes according to the normal operation condition, and 02 subfunction, the server shall stop the settings of the diagnostic trouble code. So these two things will be there in the DTCs, and the respective NRCs will be supported for subfunction not supported and incorrect message length or invalid format, condition not correct, and 31 request out of range. So this is the request message from the client and response message. So the service ID will be the 85 control DTC settings, and we'll get the service ID plus 40, that is the exa value C5. So you can go through what is that value, and the subfunction we have given as a 01 things. Next, this is the one of the ISO TP frame as we discussed. So the ISO TP will be given in the next video in detailed how this CAN TP flow will be works. So coming to the read data by identifier, so this is the most important service ID. So we call it as read data by identifier. So the read data by identifier shall uh, have uh, the read data by identifier service allows to the client to request the data record values from the server and identify by one or more data identifiers. The client request message contains one or more 2 bytes of the data identifier values. The format of the definition of the data record shall be given by the vehicle manufacturer or system supplier. So the ECU identification number like VIN number, hardware number will be given in the DIDs. So coming to the single DID, so multiple DIDs also will be there and single DIDs also we have. So how this uh, data will be represented? So the service identifier 22 and respective DID. So here we don't have any subfunction. So directly we can give the 22 respective DID F1AB or F1BB. So ECU will get the positive response with the data whether it is 8 bytes or 22 bytes based on the request and response data. So for the multiple DIDs, how we can give an example means the 22 respective service ID 1, 2, 3, 4 and AABB with again will get the positive response and respective data. So supported NRCs in the DIDs are 13 incorrect message length or invalid format, 22 condition not correct, 31 request out of range, and 33 security access denied. So no one like any other person cannot read directly the data information. So only the authorized person can only read the data information for the particular ECU. So another service ID is write data by identifier. Now we are discussing about the write data by identifier. What is write data by identifier? So the write data by identifier service allows to the client to write the information in the server internal location specified by the provided data information. The data is identified by the data identifier and may or may not be secured, like ECU identification data like supplier VIN, vehicle identification number, and in case the data will be stored in the WEPRAM. So here we have in the write data by identifier listed out some NRCs, 13 incorrect message length and 22 condition not correct, 31 request out of range, 33 security access denied and 72 general programmer failure. Next, we are going to discuss clear diagnostic information. Service ID is 14. This service allows the diagnostic memory to clear the single or multiple ECUs. The request service ID will be the 14 and the respect group of DTCs we are sending and unused byte data. So the response will comes with respect to the adding the plus 40, it will be 54 and PCA length also 02. So coming to the DTCs, what is DTCs? DTCs 19 service ID, it's a like contains the DTC code, status of the DTC, DTC snapshot record number, DTC snapshot record, DTC extended data record number, and DTC record data and DTC CVRT mask. So some listed of subfunctions also there in the 19 service ID. Why DTC we call it as? DTC is a restrictive diagnostic trouble code. So all the DTCs will be logged in the WP RAM. So we'll discuss one by one DTCs here. So 01 subfunction report number of DTC by the status mask. The parameter specifies that server shall transmit to the client the number of DTCs are matching a client defined the status mask. 02 subfunction report DTC by the status mask. The parameter specifies that the server shall transmit to the client a list of the DTCs and corresponding status matching the client defined status mask. 03 report DTC snapshot identification. The parameter specifies that the server shall transmit to the client DTC snapshot data record identification like DTC number and DTC snapshot record number. 04 report DTC snapshot by the DTC number. The parameter specifies that the server shall transmit to the client and the DTC snapshot record associated with the client defined DTC number, and this DTC snapshot record number of like FF means up to 255 hexa value. Coming to the 05 report DTC snapshot record by the DTC number, and 06 subfunction report DTC extended data record by the DTC number. 07 report number of DTC bytes by the severity mask record, and 08 report DTC by the severity mask record. 09 report severity information of the DTC, and 0A it will be report support DTC. 0B report first test failed. 03 report first confirmed DTC. 0D reports most recent test failed. 0E report most recent confirmed DTC. 0F repeat mirror memory by the DTC mask. So if you go through this 19 service ID, it is a all contains from the 0 to F means 15 subfunctions are there. So what are the NRCs will support for the 19 service ID? 12 subfunction not supported, and 13 incorrect message length or invalid format, 31 request out of range. So these are the supported DTCs will be available in the 19 service ID. We are going to discuss what is input and output control by the ID. So what is the service ID? It's 2F. The input and output control by the service identifier service is used by the client to substitute a value of the input signal internal server function and control an output actuator for an electronic system. The unit of diagnostic servers as interface a sensor and actuator module provides access to the ECU input and output devices which are pump motor lamps. It must be granted at the activation of the system components like motors, valves, etc. can be done only in the safe condition without damaging the system or components. So here we have some set of things are there. No control algorithm is active, no device controlled DTCs are latched, ECU is in the non-default session. So here we have some set of subfunctions are there. 00 report control to the ECU. The value shall indicates to the server that client no longer has control over the input signal, internal parameter or output signal referred by the input output identifier. Number of control state bytes in request 0 and number of control bytes in the positive response depends on the data identifier. And 01 subfunction reset to the default. The value shall indicates to the server that it's requested to the request input signal internal parameter or output signal interface by the input output local identifier to its default state. Freeze current state. The value of shall indicates to the server that requested to the freeze the current state or input signal internal parameter or output referred by the input output local identifier. 03 subfunction short term adjustment. The value shall indicates to the server that is to request to the adjust input signal internal parameter or output signal referred by the respective RAM. So for the input and output controlled we have 2F respective NRCs we have. So 13 incorrect message length or invalid format, 22 condition not correct, 31 request out of range, 33 security access denied. So coming to the another service ID, routine line control. So what is routine line control? The client requests to start or stop the routine line in the server or request the routine results. A routine line is a predefined sequence of action to be executed by the ECU. Once a routine line has been started, the ECU cares the sequence being to kept. Every routine line has an individual identifier contains up to 2 bytes hexadecimal value. So the service may be certain entry or exit conditions like at least one vehicle speed sensor is valid and respective things will be applied. So here coming to the subfunction, how many subfunctions we have? We have three subfunctions supported in the 31 service ID: start routine, stop routine, and request routine result. Start routine, the parameter specifies that the server shall start the routine specified by the routine identifier. Stop routine, the parameter specifies that the server shall stop the routine line specified by the routine identifier. And 03, request routine line result. This parameter specifies that the server shall return the result value of the routine line specified by the routine identifier. So here the list of NRCs we have, and before going to list out the NRCs, we have the request and response message for the respective service ID routine identifiers. Please go through this client and server request message and response message. You can get the in detail explanation. So here it will be supported 12 subfunction not support, 13 incorrect message length, and 22 condition not correct, 24 request sequential error, 31 request out of message, 33 security access denied, and 72 general programming failure. So these are the supported NRCs for the 31 service ID. So this is what. Coming to the another service identifier 34. This service ID, the request download service, is used to client to initiate the data transfer from client to the server download. After the server has received the request download request message, the server shall take all the necessary actions to receive data before it's sent to the positive message. So here we have the respective uh, what we call subfunctions we have. So request download server response service ID, and the respective data format identifiers we have, and address and length format identifiers we have, and memory address, memory size also we have. And for the 34 service IDs, we have respective NRCs will support like incorrect message length or invalid format, 22 condition not correct, 31 request out of range, 33 security access denied, 70 upload download not accepted. So next, transfer data. The transfer data is used to by the client to transfer the data either from the client to the server or server to the client. The data transfer direction is defined by the preceding request download or request upload service. If the client initiated the request download, the data has been downloaded including into the parameters. Transfer the request parameter in the transfer data request. If the client initiated the request upload, the data to be uploaded including the parameters like transfer response parameter in the transfer data response. So here like supported NRCs are incorrect message length or invalid format, and 24 request sequential error, 31 request out of range, 71 transfer data suspend, 72 general programming failure, 73 wrong block sequential counter, and some other 92 specified by the OEM voltage too high, voltage too low. Request transfer exit. This service is used by the client to terminate a data transfer between the client and server, or upload or download. So here the respective service ID NRCs will support incorrect message length or invalid format and request sequential error. So here we'll discuss about the P2 P2 star timer also. It is one of the important parameter like P2 server is a performance requirement for the server to start with the response message after reception of request message. So some OEM will specify the P2 P2 start timer. So some it will be 500 milliseconds and P2 start timer will be exceed 5000 milliseconds. So P2 star can server we cannot performance requirement for the server to start the response message, the transmission of the negative response with the 78 request sent response waiting. So this is about the P2 P2 star timer, and S3 server timer we call it as S3. So time for the server to keep a diagnostic session other than the default session active while not receiving any diagnostic response. So this is about the P2 P2 star timer and S3 timer. So we'll detail what is a flashing program. In the 10 service IDs we have seen the programming session how this flashing will be happen. So it start from the basic sequence of the flashing program. Start with the read data by identifier 22 service ID. Next diagnostic session control, that to 1003. What is 1003? It's a extended session. After that it will goes to the service routine line control. It will check the program precondition 31010203. Next it comes from the control DTC settings of common communication control disable non diagnostic communication, that is 2801. And after that it will goes to the diagnostic session control, again the programming session 03. And after that it will pass from the security access request seed 2701 and transfer the key 2702, write data by identifier. Then it will goes up to the again routine line control to erase the memory. After that request download 34 and transfer data 36 and request transfer exit 37, routine line control check memory and routine line control check reprogramming dependency. After that again it will goes to the ECU reset, again communication control enable non diagnostic communication 2800 and control DTC settings on 8501, and diagnostic session control comes to the again default session 1003. This is the basic programming, like in the diagnostic how we are going to flash the software in the ECU. So how this S3 server and P2 P2 star, these are the very important. Once again I am repeating, P2 can, it's a timeout of the client to wait after successful transmission of the request message for the start incoming response message. P2 star means enhance the time control for the client to wait after the reception of a negative response message with the code 78. P2 can server is a performance requirement of the server to start the response message after the reception of a request message. P2 star server, it's a performance requirement of the server to start with the response message after the transmission a negative response message with NRC 78. So in generally the diagnostic will have the multiple uh, things are there, like we have covered only ISO 14229, that is -1. It is for the road vehicle and unified diagnostic services. So once again thanks for watching this video, and please do like, subscribe and share. You will get the more information about the automotive industry. Next video we will discuss about the diagnostic, like how DCM flow in the AutoSAR, and what are the important questions for the diagnostic. All this will be listed out, and I will present in the one video. Once again please like, share and subscribe. Thank you. Thanks for watching this video.